Welcome to VEDHA online classes. VEDHA online classes is providing the live online tuitions for intermediate CBSE, EAMCET, IIT-JEE, BITSAT. So in probability, one of the most important question is addition theorem. This is a compulsory question. Okay, so one of the most important questions. State and prove addition theorem on probability. He'll give the question like this, or he may give the question, okay, so like this also. Okay, if A and B are any two events of a random experiment, okay, so and P is the probability function, then prove that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so this is statement. Sometimes we'll give the statement, sometimes we'll ask to state and prove the addition theorem on probability. But mostly he'll ask state and prove addition theorem on probability. Okay, so for that we have to write the statement also. Okay, statement, writing statement is compulsory. Okay, what is statement? Whatever we give. Okay, so given here as a question, that is only the statement. That means, okay, the statement is if A comma B. If we ask to write the statement, it is compulsory. Okay, so we have marks for writing statement also. Okay, that's why. Okay, if A comma B are any two events, of a random experiment, and P is probability function. P is probability function. Okay, so then prove that. Probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Okay, so this is the statement here. Okay, so now we have to prove this. After writing the statement, we have to prove this. How do we prove this? Okay, we have the case 1 and case 2. I am taking the case 1 here. Okay, so what is case 1? What is case 1 here? So I am taking the two events A and B. Okay, so here I have one event A and one more event is B. They are disjoint events. Okay, just assume that these two are disjoint events. If A intersection B is equals to pi, means there is no common elements between A and B. They are separate. Okay, so then what is probability of A intersection B? Probability of A intersection B is equals to pi. Okay, so probability of A intersection B is equals to, okay, so means when there is no elements in common, then what is the probability? Probability is 0. Okay, so whenever the sets are disjoint, the probability is always 0. So what we have to find? We have to find the probability of A union B. Okay, whenever the A and B are disjoints, A union B is equals to probability of A plus probability of B. Okay, what is probability of A? What is probability of B? The total is probability of A union B. Okay, why? Because there is no common elements, there is no common space between A and B. Okay, so A and B are disjoints, then only, okay, so we get this answer. Okay, so A and B are disjoint. Okay, so now probability of A union B is equals to probability of A plus probability of B. Now I am writing this as probability of A union B is equal to probability of A plus probability of B minus 0. I am writing. Can we write minus 0 or plus 0 for any term? So we can write. Okay, why? Because by adding 0 or subtracting 0, no change. There is no change by adding or subtracting 0. That's why I'm just subtracting 0 here. Now After that, in place of 0, I am going to write probability of A intersection B. So that means we get it as probability of A union B is equals to probability of A union B is equal to probability of A plus probability of B minus 0. I am replacing with probability of A intersection B. Okay. So why? Because probability of A intersection B is equals to 0 it is. Okay, when disjoint sets, the intersection part is okay, so not there, that's why the probability is 0. Okay, so is it proved or not? Is it the required answer? Yes. Okay, so probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. This is only the required solution here. Okay, so this is for only case 1, only for case 1. Then what is case 2? What is case 2? If A intersection B is not equal to 5, that is case 2. Okay, if A intersection B is not equal to 5, okay, then the sets are like this. A and B are different. Okay, so we have A set here and B is another set here. Okay, some part is common between the A and B, some part is common. Okay, this A may be bigger or B may be smaller. Okay, maybe bigger, whatever it is. Okay, maybe equal. Okay, so here we have some common area between A and B. So A and B here. Okay, so now A union B is nothing but the combination of A as well as B, but the place whatever we have here, the common part, we calculate. Okay, so for 2 times, means whenever we consider A, we okay, so we take that area, and whenever we are taking B, we take that area again. Means we are taking that area for twice. Okay, so that's why probability of A intersection B is not equal. Okay, so not equal pi means, okay, some part is there, some value is there. Okay, it is not equal to 0. Probability is not 0. Okay, and A union B. Okay, so A union B is union of disjoint sets. Okay, here A minus B I am taking A minus B. What is A minus B? Okay, so from A we have to subtract B. A minus B means from A we have to subtract B. Subtracting B means don't go inside the B, even though it is present in A. Okay, so we'll leave that area. Even though it is present in A, we'll leave that area. Means whatever the area is common, okay, present in A and B, we are going to leave that area. Okay, this is A in A minus B. This is A minus B. Okay, so now here and this is A intersection B. This area is A intersection B. Okay, so now here the area is A minus B. From A we are subtracting. Okay, so B completely. Okay, so and this area is A intersection B. Okay, common between A and B. Okay, so A union B is the union of this A minus B and B. If we combine this A minus B shaded, okay, so yellow color shaded part as well as B. Okay, if we combine both, that is union, the total A and B. Okay, so disjoints. Okay, so disjoint sets A minus B comma B. Okay, since they are disjoint, intersection part is 0 between these two sets. There is no common area. That means we can write it as probability of A union B is equal to probability of A minus B plus probability of B. We can write it like this. We can write it like this. Okay, take it as equation number 1. Take it as equation number 1. And A is also, if you take A is also combination of two disjoint sets. Now A is union of disjoint sets A minus P comma A intersection B. Okay, so if you take A, this is A, in this A, okay, we have two sets. One is A intersection B and A minus B, this shaded part, as well as, okay, so this is A intersection B part. These two are different. Means they are disjoint sets. Okay, so that means probability of A is equals to sum of these two probabilities. Probability of A is equal to probability of A minus B. Okay, so union A intersection B. Probability of A, we can write it as probability of A minus B union A intersection B. Okay, so that means, okay, since they are disjoint, both are disjoint, okay, so we can write it as probability of A minus B plus probability of A intersection B. Probability of A intersection B. Okay, so union replaces with plus. When they are disjoint, there is no common part, probability becomes 0. Intersection part probability becomes 0. Okay, so since here A minus B comma A intersection B are disjoint. Okay, whenever the two sets are disjoint, directly we can add the probabilities of those two. And what is probability of A minus B from this? What we can write the probability of A minus B? Okay, probability of A minus B is equals to, okay, so left side we have probability of A. So take this right side probability of A intersection B, that side. That then becomes probability of A minus probability of A intersection B. Okay, take it as equation number 2 and substitute this probability of A minus B value. Okay, so in this equation 1, substituting equation 2 in equation 1. Substituting equation 2 in equation 1. Okay, then probability of A union B is equals to probability of, okay, so probability of A minus B. Probability of A minus B. Probability of A minus B replaced with probability of A minus probability of A intersection B. Probability of A minus probability of A minus probability of A intersection B. And after that, what we have here? We have probability of B, write that as is, plus probability of B, plus probability of B. Now, probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. A intersection B. This is the required. Okay, so proof from case 1 and case 2. We proved in both the ways. Okay, therefore, okay, from case 1 and case 2, from case 1 and case 2. Okay, so probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Hence proof. Okay, this is one of the most important questions. Okay, LAQ. Do you have a dream of scoring up to 75 by 75 in intermediate maths of Telangana and Andhra Pradesh? Do you want the pass guarantee intensive classes or videos? Do you want to learn the mathematics from zero to hero level? Then this is the right place for you please like, share, subscribe our VEDHA online classes.